be wondering, okay, it's the 2nd of May. We've already taken our final. Seniors have 20 more days yet. Juniors and sophomores have a little bit longer yet. What are we going to do? Okay. Well, we are going to do 2 more topics, parametric equations and polar equations. Okay. So we're going to deal with, it's a bird, it's a plane, it's parametric equations today. We may have some formatives, we don't know, but we will for sure have a test on these 2 topics. We're going to combine them into one test. We're going to have a test on these 2 topics on Wednesday, May 21st. Okay? So, and then Thursday, May 22nd is seniors' last day, and we never test on that day, so, because we're not mean like that. Okay? Right? And the nice part is we've already taken the final, so we don't have to try and squeeze that in towards the end and then worry about grades and stuff like that. In terms of mine, I am through Form A of Day 1. That's how far I'm at. Okay, and I'm not going to put grades in the grade book until I get both Form A and Form B done, because then it's one grade in the grade book. And then if you get notifications on your phone from Infinite Campus, it's going to go crazy for like a couple of hours, because I'm going to be turning stuff off and turning stuff back on and all that stuff, and because I got to pull out your trig grades for NTC to calculate your NTC grade. So just so you okay. All right. So here we go. We are in the. You have a note packet. That was the packet that you got. Now we are using calculators, and ha ha he he. Leave it in English. Okay. All right. It's hilarious, I know, for me to have to go through and change calculators from German back to English. Okay. Ha ha he he. We all get the joke. Okay. All right. Okay. So we'll get to those here in a minute. So let's talk here a little bit about functions. Okay? You've dealt with functions now for the better part of 5 or 6 years. Okay? Because you started them back probably in 7th grade-ish. Okay? All right? So you've always known a function, f of x equals, or y equals f of x, could be something along the lines of y equals 3x plus 2. That's a function. Yes? Right? Could be a quadratic function. Could be f of x equals 3x squared plus 7x minus 4. Okay? You've dealt with those in numerous different lookings at, all that fun stuff. Okay? They come in different shapes, different sizes, different forms. Okay? On all of those functions, okay, x has been your independent variable. My P didn't P. My P looked like a D. Which means that it was the input. Okay? Which means you plugged it into the function. Y, or f of x, was the dependent variable, or the output, and it got you the point x comma y, which you then plotted. And you make the graph, and then you connected the dots, and you went on about your business. Shouldn't be groundbreaking, any of that which I just put up there. Okay? Today, we're going to start parametrics. Functions are in 2 variables. Parametrics are in 3 variables. Okay? So now we're going to introduce the variable t, which is going to stand for time. And x is going to be the horizontal function of t. So that means t is now going to be your independent or your input, which means both x and y are going to be your dependent or your outcome, your output. Y then is going to be your vertical function, together then you are going to plot the point. Instead of x comma y, now it's going to be, wish you would have done, we should have done here f and g. Change that to g here, because it should be two different functions, because they're not always going to be the same. Yeah? So your output then is going to be f of t, g of t, and then that's what you plot. Because that'll give you then an x comma y. Okay. Let's do it. Okay. We want to sketch the following parametric equation for t on that one by hand. Now, t here is going to be time, and we're going to have some kind of, whoa, tap the brakes. Why did that go crazy on me like that? We're going to have some kind of time restriction. So our t values are going to only be between -3 and +2. So this is going to be -3, -2, -1, 0, 1, and 2. Our t values have to stay within that range. They don't go farther, they stay right there. Okay? Well, now I take my t value and I plug it into my x function. Well, my x function is x equals t plus 1. So if t is -3, -3 plus 1 is -2. -2 plus 1 is -1. -1 plus 1 is 0. 0 plus 1 is 1. 1 plus 1 is 2. 2 plus 1 is 3. Yeah. Then I take my t value and I plug it into my y function. -3 squared is 9. -2 squared is 4. -1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. Those now become the points then that we plot. So this would be the point here. This would be -2, 9. Left 2, up 9, plots my point right there. negative 1 comma 4. Right there. 0 comma 1. 1 comma 0. 2 comma 1. And 3 comma 4. Just wait before you draw. Do not draw, because I already saw it 3 times. Remember, our time is restricted, correct? So this is not a parabola that goes on forever. This parabola stops at both of those spots. If you draw this parabola shooting off up to the space in both directions, you are wrong. And we will mark it wrong because we have a restriction on our time. Okay? Parametric functions have a restriction on their time. They stop. Okay? Alright? Now, the other thing is we need to eliminate the parameter. So if we eliminate the parameter, then what we're doing is we are taking it from a parametric function and we're putting it back into a regular old Cartesian coordinate function. Okay? So how we do that is we've got x equals t plus 1, and we've got y equals t squared. One of those we need to solve for t. Which one do you think is easier to solve for t? The x or the y? The x is easier to solve for t. I'm going to subtract 1 from both sides, and that's going to give me x minus 1 equals t. Agree with me on that? Okay? Then I'm going to take that and I'm going to substitute it into the other one in place of t. So now I get y equals, instead of t squared, I get x minus 1. And if you try and tell me that x minus 1 quantity squared is x squared plus 1, I'm going to start throwing paper through windows. Because I don't know how many of you gave me this. This is going to ring a bell for some people. Oops, not sine squared. Oops, come on, come on. Is that true? No! That's Hall of Fame bad. You know how many we got of those? We made 130 copies because there's roughly 125 pre-calc students. You know how many we got? Over 60. Yeah. It's bad. And we've even talked to you about that's Hall of Fame worthy. In the Hall, I shouldn't say Hall of Fame. Hall of Shame worthy. Okay? What is really x squared minus 1, or x minus 1 quantity squared? You should be able to do that in your head. Right? What is it? Squared minus 2x plus 1. Okay. And now we've eliminated the t. Which, if we think back to our Algebra 2 days, when we were doing parabolas and quadratic equations, that's a parabola, yes, opens up because it's got a positive a value, If I go back here, it would be centered at 1, 0, or the vertex, I should say, not centered. The vertex would be at 1, 0. I've got a parabola with the vertex at 1, 0. I just took a chunk of it. I didn't take the whole thing. Okay? Good? Let's do a trigonometric one. Okay? Sketch the following parametric equation for t over the 0 degrees to 360 degrees. Let's go by hand. Okay? All right? So 4 cosine of t is x. 4 sine of t is y. So in my brain, I'm thinking for my x values, I'm going to have 4 cosine of 0 degrees, right? Well, what's the cosine at 0 degrees? 1. So what's 4 times 1? 4. Then I'm going to have 4 cosine of 45 degrees. What's the cosine at 45 degrees? So what's that going to be? 2 root 2. Okay. You guys all have calculators? What is 2 times the square root of 2? .828. Okay. Then you go to 90. What's the cosine at 90? Times 4. Okay. Then we go to 135. What's the cosine at 135? Negative root 2 over 2, right? So that's going to be negative of 45, so that's going to be negative 2.828. Everybody see that? 45 was positive root 2 over 2. Only thing that's changing is that cosine value. At 135, it's negative root 2 over 2. Okay? So it's just a negative. 180 degrees. What's my cosine value? Negative 1. So that means this is going to be negative 4. 225. What's my cosine value? Negative root 2 over 2. So then that's going to be negative 2.828. 270, what's my cosine value? 0. So that means that's going to be 0. 315, what's my cosine value? Root 2 over 2. So then we're back to positive. 360, what's my cosine value? 1. So then that's 4. Okay. Now we got sine values. Oops, not theta. What's 4 times the sine? What's the sine at 0? 0 times 4. Then we've got 45. What's the sine at 45 degrees? Root 2 over 2. So that's going to be 2 square roots of 2. Yes? Which is going to be 2.828. 90, what's the sign at 90? 1. $135, what's the sign at 135? Positive? Positive, so then that's going to be positive. 180, what's the sign? 0. 225, what's the sign? Negative root 2 over 2, so that one's going to be negative. 270, what's the sign? Negative 1. 315, what's the sign? Negative root 2 over 2. And at 360, what's the sign? 0 again. Okay. So let's graph those points. 4, 0 is right here. 2.8, 2.8, somewhere kind of right in there. 0, 4. Negative 2.8. Positive 2.8. Negative 4, 0. Negative, negative. 0, negative 4. So this one started here. And made ourselves a nice little circle. In trig parametric functions, we have to remember our old friend the hammer when we are eliminating them. So if x was equal to 4 cosine of t and y was equal to 4 sine of t, then I need to get cosine of t by itself. So I'm going to go x divided by 4 there is equal to cosine of t. And I'm going to go y divided by 4 is equal to the sine of t. Now, if I've got cosine squared of theta, well, that's the same as cosine squared of t. Likewise, sine squared of theta is sine squared of t. So this is really the hammer here is like that, which would be x over 4 squared and y over 4 squared. X over 4 squared becomes x squared over 16. Y over 4 squared becomes y squared over 16. And that equals 1. I can multiply all of these by 16, and I get x squared plus y squared equals 16, which is the equation for a circle centered at the origin with radius of 4. X squared plus y squared equals r squared. So my radius is 4, which is what we have drawn right there. Okay? Let's go to the calculators. First thing that you're going to want to do is you're going to want to turn your calculator on by hitting the on button. And then you might as well just double tap it right away so that this screen comes up. You are going to want a new document. I don't do scratchpad stuff. I do new documents. No, you do not want to save anything. Okay? You are going to be making a graph. We're going to add a graph here first. Okay? But we are currently in regular graph. We're in regular function graphs. We need to be in parametric graphs, so we're going to hit Menu. We're going to go to Graph, Entry, and Edit. Which one do you want to select? Parametric, number 4. Okay? Now, if you'll notice what happens in your graph entry point of where you type in your functions, now you've got a specific line for your x function. Now you've got a specific line for your y function. You've got a t value and you've got a t step. Okay? Right? So our first function that we are going to be doing on the calculator is going to be 5 cosine of t for x, 3 sine of t for x. Notice my t value is in what? It's in radians, because we see a pi, so we need to make sure that your calculator is in radians. Okay? Otherwise, it will not work. Okay? Make sure that your calculator is in radians first. Okay? Then, our first function was 5. Cosine is under trig. Cosine of t. You gotta have the t there. It's not x, because it is a function of t. Our our y was what? 3 sine t? 3 sine of t. We said that we needed to have a t values from 0 to 2 pi. 6.28 is 2 pi, correct? Roughly. Okay. Yep. So that's 6.2 pi. Your t step on the calculator, that's how often it's calculating it. For instance, back here, I'll go back to the very first example we did. Back here, our t step would have been 1. Because we calculated the value 1 unit away. Here on this next one, our t-step would have been 45 degrees. We calculated it every 45 degrees. So this is saying that we are calculating this every 0.13, which is pi over 12. Okay? Right? And then when you hit enter, you should see an ellipse. Oops, I don't want that one. I wanted that one. Okay? You would then need to recreate that on your paper. So that's what it should look like once you type it in. And this is what it should look like coming out. Okay? All right, so hold on before you leave. On your way out, you need to grab one of these. I'll put them up here on the stool right up here. You need one of those on your way out. It's due. It's your entry ticket on Tuesday. Okay?